This lesson covers the probability of compound events. Number 1, a disc jockey has 8 songs on this upcoming hour's playlist. 2 are rock songs, 2 are reggae songs, and 4 are country songs. The disc jockey randomly chooses the first song to play, and then she randomly chooses the second song from the remaining ones. What is the probability that both songs are reggae songs? Write your answer as a fraction to the simplest form. The key here is they said remaining, so that means there was no replacement. So they're not going to play the same song 2 times in a row. So the possibility of it happening the first time is there's 2 of them out of the total of 8. And then they played that song, so there's no longer 2 of them, there's 1 of them left. And there's no longer 8 songs left, there's 7 songs left. So the first event is 2 out of 8, and the second event is 1 out of 7. Multiply straight across. 2 times 1 is 2. 8 times 7 is 56, which reduces to 1/28. And again, you could have canceled. You can cancel diagonally, or you can cancel up and down. And 2 goes into 8 4 times, and 2 goes into 2 once. So that would have been 1 times 1, which is 1, over 4 times 7, 28. Or, I know you love your calculators. You could have just done it in your calculator. So you would have had 2 divided by 8, and then times 1 over 7. Hit enter, and then math, enter, which gives you 1 out of 28. Next up, a box has 13 candies in it. 5 are caramel, 4 are peppermint, and 4 are toffee. Yolanda wants to select 2 candies to eat for dessert. The first candy will be selected at random, and then the second candy will be selected from the remaining candies. So again, there is no replacement. They're not putting back the candy, which is good. She ate the candy, it's gone. What is the probability that the first candy is a caramel? Well, there were 5 caramels out of 13 candies, and the second one's a peppermint. Well, all 4 of those are still there. So there's still 4 there out of, instead of 13 candies though, there's 12 of them now because we ate one of the caramels. So there's 4 of those left. But there's also 4 peppermint. Again, multiply them together and you get 0.128 to the nearest 3 places. They said to take it to the thousands. Number 3, a club with 45 college students is doing volunteer work this summer. Each student is volunteering at one of 4 locations. Here is a summary. So some are at the hospital, 18 of them, 13 are at the Tutoring Center, 4 at a nursing home, and 10 are at a library. 3 students from the club are selected at random without replacing them. What is the probability that none of the 3 students volunteer at the nursing home? So how many are not going to the nursing home? 10, 13, and 18. If you add all 3 of those up, it adds to 41 out of the 45 students. So again, we pick one of those people and they're gone, so we don't have 41 of them anymore. We have 40, and instead of 45, we have 44 left to choose from. And then again, so you choose another one, so there's 39 left out of 43. So 45, 44, 43, 41, 40, 39. Multiply them all together, 0.712, or to the nearest thousands, 0.751. Again, on the calculator for you, I would do it all at once. Parentheses, 41 divided by 45, and then 40 divided by 44, and then times 39 divided by 43. And there's the answer, 0.751. All right, number 4. An urn contains 8 pink and 5 black balls. 6 balls are randomly chosen from the urn in succession with replacement. So this time they're putting them back, like it never even happened. What that is, after each draw, the selected ball is returned to the urn. What is the probability that all 6 balls drawn from the urn are pink? Well, there's 8 pink ones out of a total of 8 plus 5, 13 balls. And you're putting it back, so the next time it's still there, so the same thing is going to happen all 6 times. The same event is happening every time because you're putting that back in and redoing it from the beginning every time. So you can multiply those all together 6 times, or just do 8 over 13 to the 6 on the calculator. So 8 divided by 13, caret key is above the division symbol, so caret 6, enter, and so that's 0.054. Number 5. A TV studio has brought in 9 boy kittens and 6 girl kittens for a cat food commercial. The director is going to choose 8 of these kittens at random to be in the commercial. What is the probability that the director chooses 5 boy kittens and 3 girl kittens? So we're going to pick it. So the event is picking the boy kittens, picking 5 of them, picking 3 of the girl kittens. Out of the total event, which was 15 kittens altogether, picking 8 of them. So I used a combination and not a permutation because we're just picking 5 kittens. The order of the kittens don't matter. We're not choosing one of the kittens to be the president or the vice president. We don't have the first place kitty and the second place kitty. There's no order that's to this event. We're just getting 5 boy kitties out of the total of 9. So the first event is choosing 5 boy kitties. So you're going to do 9 combination 5. The second event was choosing 3 girl kitties out of a total of 6 girl kitties. And again, you have to divide that event by the whole event then. So the probability of the whole event being picking 8 kittens out of 15 kittens. All right, so again, on your calculator, you're going to go type in the number 9 first, so 9, and then go math, over to probability, down to choice 3, 9 choose 5, and then I'm going to multiply that by, so it was 126, and then multiply that by 6 combination 3, which gives me 25, 20, and then I need to divide that by 15 combination 8. There we go, 0.392 to the nearest thousands. They said the 3 decimal places, and so the 1, the number after it's 5 or more, so it rounded that up to a 2. The next one. A marble is selected from a bag containing 8 marbles numbered 1 to 8. The number on the marble selected will be recorded as the outcome. Event A, the marble selected has a number from 2 to 5. Well, from 2 to 5 includes the number 2 and 5. So that's the numbers 2, 3, 4, and 5. The number selected is odd. 1, 3, 5, and 7 are all odd numbers between 1 and 8. So the first event, they'd like to know what the intersection of A and B is. Well, the intersection is what they have in common, what is in one and in the other one. And the number 3 and the number 5 are in both events. So that's in the event of and. The event A and B happens. Again, that means intersection when you see the word and. So it's 2 numbers. The next one's or. Or is the union, or everything that's there. It could be in A or it could be in B, so it's in all of it. It's in the union of all of it. So event B, I wrote it down here, is all the events in A, and you got to put events B in, but you don't write the 3 and the 5 twice. I don't know if your teacher would mark it wrong or not. It's just not, again, good math grammar to write it twice. It just looks sloppy. Again, like capitalizing a sentence or putting a period at the end, it's just, I don't know. It's up to the teacher whether they take off a couple demerits or not for that. The last one, what's the complement of event A? The subset of all outcomes in the sample space that are not in the event is what the definition of complement is, which means what's not there. So if we look at event A up here, the numbers 2, 3, 4, and 5 are in it. So what's not in it? What's not in it were the numbers 1, 6, 7, and 8. So that's the complement of it. Whatever's not there is the complement of it. Next one, the Venn diagram below shows 16 students in Mr. Chen's class. The diagram shows the memberships for the softball club and the volleyball club. Note that Chris is outside the circle. Here he is. Since he is not a member of either club. Let A denote the student is in the softball club. So all these students are in the softball club. Let B denote that they are in the volleyball club. All right, so what's the probability of event A being in the softball club? Well, if you add up all the names, they add up to 9 of them out of a total of 16 students, so 9/16. The probability of B, or being in circle B, add up all the names. You add up all the names, there's 10 of them out of 16 total in the whole group, which is 5/8. The next one says A or B. Remember, that's the union of them. So it's everything in A, R, and B. So it's everything in both circles, which is all the kids except for poor Chris. So all the kids were 16, and take off Chris, that leaves 15 of them left out of 16. So 15 out of 16. So it's everything in both circles except poor Chris, so it's 15 of them out of 16. Okay, the next one. A and B, that's the intersection of the two circles here in red. So that's those 4 students out of the total of 16, which is a fourth. Then they just want you to take the numbers that you just got on all of these answers, the probability of A, 9/16, plus the probability of B, 5/8, then minus the probability of A and B, which was 1/4. And when you do that, you get 15/16, which matches this one with the word or. So that's how come the answer on this one's or. A 6-sided die with faces 1 to 6 will be rolled once. The 6 possible outcomes are listed below. Note that each outcome has the same probability. Complete parts A through C and write the probabilities as fractions. Check the outcomes for each event below, then enter the probability of the event. So if you roll an odd number, 1, 3, or 5, which is 3 out of 6, a half, rolling a number less than 3. Less than 3 are the numbers 1 and 2, so that's 2 numbers out of 6, or a third. The next one, events A and B, rolling an odd number and rolling a number less than 3. So it's an and, so it's the intersection. It has to be both things. It has to be an odd number and a number less than 3. So looking here above it, you'll see that it's both the number 1. Both of them are checked. So it's 1 out of 6. And then they said or. Or is all of them. So or would have been all the events. So it would have been this one, this one. So all of them except 4 and 6. 4 and 6 didn't happen in A or B. So it's everything but 4 and 6. So that's 4 of them out of 6, or 2/3. Okay, again, they just want you to plug in the numbers. So A was a half, B was a third, and then the probability of A and B, which was right here, was 1/6. And then you do the math and you get the other answer for the last one, which was 2/3. So it matches the word or. All right, last one here on the page. Let A and B be 2 events. Let the probability of A be 0.79 and the probability of B be 0.05. A, find the probability of A or B. Or, remember that's the union of the 2 of them. So everything in A and everything in B. When it's or, it's all of it. Well, if they're mutually exclusive, here's 2 mutually exclusive circles. There's no overlap to the 2 circles at all. Unlike that one problem we looked at here about the volleyball and softball team, they had the overlap of 4 of them. So when they're mutually exclusive, the 2 circles don't overlap at all. So if we're going to find the probability of A or B, we're going to add them up. But if they overlapped, we would have had to subtract off the intersection of them. You have to subtract off the intersection, because if you add A and then you add B, the overlap would be counted twice. And you don't want to count that twice. That's why you subtract it off once. By subtracting it off once, you're subtracting off the fact that you added it up twice with A and B. So it's mutually exclusive, so there is no overlap. So you just add A and B together. And the next one, they are independent, which doesn't mean that they're not mutually exclusive. So there's going to be some kind of overlap. When there's an overlap, the way you find it is multiplying the probability of A times the probability of B. So you're going to take the probability of A, which was 0.79, plus the probability of B, 0.05, minus the 2 numbers multiplied together, and you get 0.8005. I think this one didn't say to round to any particular number, so just leave all of it. A company has both male and female employees. The company has shirts and jackets with the company logo to give away to employees. For each of the company's 192 employees, a manager asks which piece of clothing the employees prefers. The preferences based on gender are summarized in the table below. All right, the first one here says, what is the probability that the employees prefer a jacket? Well, 77 and 35 of them like the jacket better out of the 192 employees. They told us at the very top what the total amount of employees were, and you get 0.58 to the nearest hundredth. Next one, what's the probability that the employee is female or prefers a jacket? Well, so prefers a jacket or female, so we have to add that 19 on. So jacket and female. Don't add the 35 in twice. You're just going to use it once. So add those three numbers, divide by 192, and it's 0.682 to the nearest hundredth. Number 11, at a certain pizza parlor, 61% of customers order a pizza containing onions. So onions are 65%. 54% of the customers order a pizza containing sausage. So sausage is 54%. And then 42% of them order a pizza containing onion and sausage. So the overlap, remember, and is the overlap or the intersection. So in the intersection, it's 42. Okay, the quick answer for what you do now that you know that the overlap of the two circles is 42, you take the 42 and subtract it from the other two circles. So minus the 61 is 19, minus the 54 is 12. Because this whole thing is 61, the little piece in here is 42, so what remains is 61 minus the 42, which is 19. Add the two together, you get the 61 in the whole entire circle, but the overlap of it's 42. All right, so they want to know for the actual answer here, they want to know, find the probability a customer chosen at random will order a pizza containing onions or sausages or both. So what you have to do is onions or sausages are the both. So you're adding all three of them up. So 19 plus 42 plus 12 gives you 73% or 0.73. Next one. Number 12. Suppose that A and B are independent events such that the probability of A is 0.2 and the probability of the complement of B is 0.7. Find the intersection of A and B and find the union of A and B. All right, well, we know what A is, it's 0.2. If the complement of B is 0.7, then what B is 100% minus the complement of it, which gives you 0.3. When you add the complement and the original number back together, they add to 1 or 100%. Because we learned on the other page that a complement is everything that doesn't happen in the event. So if 0.7 happened in the event, 0.3 didn't happen in the event. So they add up to 1. All right, so the probability of B is 0.3. The probability of A then is 0.2. So the intersection of A and B is the probability of A times the probability of B. So A was 0.2, B was 0.3. Multiply them together, you get 0.06. The union of them is everything in A and B, but then subtract off the intersection of them. We talked about that on the last problem. You have to subtract off the intersection of them, because if you don't, what you're doing is counting that twice. When you add circle A plus circle B, you're adding up the middle of it with both of them 2 times, so you subtract it off once. So that's how come you're subtracting one intersection off of A and B. So the probability of A again was 0.2. The probability of B we solved for and got 0.3, and then multiply those two numbers together and you get 0.44. All right, 13. A spinner has 6 equally sized slices numbered from 1 to 6. Some are gray and some are white. Letter A, what is the probability that the wheel stops on a white... What is the probability that the wheel stops on a white slice? Well, there's 4 of them out of 6. So 4/6 or 2/3. What is the probability that the wheel stops on a white slice given that the wheel stops on a number less than 5? Okay, so given that is the denominator. Whatever is in the given that, and the given that was a number less than 5, which was 1, 2, 3, or 4. So there's 4 possibilities for that. And then the top of it is the intersection of the two events. So being a white slice and a number less than 5, it has to be both of those things, a white slice and a number less than 4. So a white slice less than 4 are the numbers 1 and 2. So there's 2 numbers that are less than 5, and they're also white. So 2 out of 4 are a half. The Venn diagram below shows the 14 students in Miss Collins' class. The diagram shows the membership for the chess club and the science club. Let A denote the event the student is in the chess club. Let B denote the event that they're in the science club. So this is event A, everybody in that circle. Event B is everybody in the science club. The outcomes for the event A are listed in the circle on the left, and the outcomes for event B are listed in the circle on the right. Note that Pablo is outside of all of them because he's not a member of either club. Find the probabilities of the events below. So the probability of A, if you add up all the names in A, there's 8 of them out of 14 students altogether. So 8/14ths. And then the probability of B, there's 7 people in the circle out of 14 names total on the whole thing, or a half. The and, remember, is the intersection of the two circles, and there's 2 names there out of 14, or a seventh. And then they want A given B, so the given B part, again, sticking to what I said on the other paper, the given B is how many that were in B, which was 7. And then the top number is the intersection of A and B, and there were 2 people in the intersection, which made it 2/7. If you wanted to, you could do like the whole probability thing, but the fact is the denominators always cancel out because you're dividing by the same numbers. So the probability of the intersection of A and B was 2 out of the total of 14. The probability of just B, we know, was 7 out of 14, which divides also just to give you 2/7. So, but yeah. All right, so then the probability of B, which was a half, times the probability of A given B, which was 2/7, equals 1/7, which was that one down there. So the probability, well, it matched with this one down here. So the probability of B times the probability of A given B. The coin is tossed 3 times. An outcome is represented by a string of the swords HTT, meaning heads on the first toss, followed by 2 tails. So there's 8 outcomes possible because you had 3 events happening. Each time it was a tossing of a coin with 2 choices, heads or tail. Multiply them together, there's 8 possible. So the next one here, alternating heads or tails was twice on an 8, exactly 2 tosses or tails happened 3 times on an 8. Alternating heads and tails with either coming first happened once, 1 out of 8. And then they want to know event B, exactly 2 tosses are the tails, which happened here on a 2 of them, so that was a half. And again, on the last one, when you plug in the numbers, you get that it matches up with choice C. On the next one, it says for each set of probabilities, determine whether events A and B are independent or dependent. So what you have to do is use these rules down here. It's independent if the probability of A and B equals the probability of A times the probability of B. The probability of A given B equals the probability of A, and it's also independent if the probability of B given A equals the probability of B. So the first one was independent because choice 3 was true. If the probability of B given A equals the probability of B, and it does. And on the next one, choice 2 was true. The probability of A given B is equal to the probability of A. Oh no, it wasn't choice 2. This one, let's see, A and B, that's choice number 1. All right, so it was an and. So with the and, you have to be able to multiply together the 2 probabilities, and it needs to equal it, and it does, because 1/4 times 1/3 does equal 1/12. So that's why it was independent. So that was choice number